Hi everyone. My name's Jake. I'm a junior mechanical engineer at University of California, Berkeley. I have a fair bit of experience in mechanical design. I'm currently doing my third summer internship. This one's at Procter & Gamble, based out of Ohio, but I'm working remotely for obvious reasons. And today I was just going to give you guys a quick TinkerCAD lesson on how to CAD a chess piece. So TinkerCAD is a free educational software, which is really nice. And what it does is essentially teach you the very beginnings of how to do CAD. And so we decided to do a chess piece, and this is the picture I drew my inspiration from. I ended up going for the king, just because why not? And yeah, so we're going to go through how to make this chess piece. So we're going to go to your TinkerCAD dashboard. You can make an account super easily just by putting in your email. In fact, I just did it earlier today. And this is the first thing you see. You should see a Workplan pop up and an unusual name up in the top left. Why don't we change it to something more accurate? So one of the really nice things about TinkerCAD is that it's super intuitive to use. So you kind of just go over here to basic shapes most of the time, and then you just scroll through and look for the shape that you want. So why don't we move this over to the right and then keep this on the left just so that we can see nice and easily what we are striving for. Alrighty, so the first thing that we're going to do is start at the bottom. So typically there are two ways to CAD. One of them is additively and one of them is negatively. So additively would be to start with each of these shapes and then basically build it from nothing. But then negatively would be to start with a large rectangle and then just cut away pieces of it. And that's something that you do really commonly in, say, Fusion or SolidWorks, but pretty difficult to do very well, I would say, in TinkerCAD. So we're going to do additively. It is worth noting that depending on your manufacturing process, it could be helpful to do it negatively, and that a lot of metal components, at least at the college and some industry levels, are negatively manufactured through mills, lathes, and CNCs. I'd be happy to do another episode on that if you guys are interested. But in this case, a lot of things that you're going to make in TinkerCAD, you would end up 3D printing. So it's totally fine to do additively. Because the concern with doing it additively for a piece that you're going to negatively manufacture is it actually manufacturable, which is something that as an engineer, it should always be in the back of your mind. Great. So why don't we start at the bottom? It looks like the very bottom shape that I have is going to be a half sphere. So why don't we drag this out? And as you can see, this half sphere looks pretty different in a variety of ways. For one, its angle is much steeper, I would say. As you can see, it goes much higher. So why don't we just bring this down to, I don't know, 2? Yeah, that looks a lot better. So now you can see it's starting to look more similarly. And again, if I want to just recenter this piece, as you can see, I'm slightly off to the left right now. If I want to recenter it, I can hit this button, and now it's in the center of my screen. Again, that's this one right here with the little square. You can also just hit the key F on your keyboard. Perfect. So now what we want up here, it looks like there's another one of these. And I could drag in another half sphere and then resize it and then flip it around or rotate it. Or more easily, I could just click on this and then go over here and hit mirror. And what mirror does is it essentially mirrors your object across a plane. In this case, it's going to be the center plane of our object. By the way, you can also hit M on the keypad, as you can see in green right there. But you just click mirror, and then this is the axis that we're going to flip it over. Oh, pardon me. So when you use mirror in TinkerCAD, it's destructive in that it destroys the original piece that you are mirroring. So in this case, since we actually want this original piece, what we have to do is Command C, Command V in order to paste that exact piece over here. And then now we can mirror it over this axis. And now we're in business. So now we just want to bring it over to the same point. And then why don't we look at it from the side? Yeah, that looks pretty good. So now what we want to do is build this piece that looks like another half sphere. So why don't we drag another? This time we're not going to be mirroring anything because the size is actually quite different. But we will have to move this piece vertically upwards because as you can see, it's a little bit too low right now. So I'm just going to click on this right face so that we get a nice accurate representation. And then I will drag this upwards with this button. And then why don't we go back to the top face to move it over. And now we'll look at it diagonally just to make sure everything's flush. So yeah, that seam right there looks like there's no air in between. So we can say that looks about right. When I look at this CAD on the left, I see, well, I did the CAD earlier, so I actually know, but this half sphere is a little bit squashed. So what we can do is click on this, and then why don't we just squash it down a little bit, make it a little bit less rounded. And I think that's because if we go back to the chess piece that I modeled it off of, what we really wanted to do was make sure that the concavity of this piece matches up with around here. All right, so we're looking pretty good. Now we're going to be doing this piece. And so what I could do is I could mirror this. Let's see, let me copy and paste it first. And then now I'll move it over here, mirror it over the vertical axis, and then move it upwards. Go to the top view, move it over here to be relatively centered. And what we're gonna do next is make it taller. So then we would have something like this. Interestingly enough, this is basically what we call a paraboloid. So if I were to mirror my paraboloid over the vertical axis, and then drag it upwards, and then if I wanted, and then if I wanted to extend it. It's very similar to a paraboloid. In fact, it might be the same depending on how they define it, although it looks like the slope is a little bit differently here. So just for using different shapes, we're just going to use the paraboloid. It really doesn't matter which one you use if you're following along. So why don't we go to another view so that we can move this more easily into place. And as you can see down below, down here, you can see a projection of the object that you're moving. So this dotted line that boxes this object is projected onto the work plane below it. So that's a really easy way to help line it up. So as you can see, this line is a little bit too far to the left, as is this one. So I need to move it to the right one. And now its footprint looks pretty good. Oh, looks like I have to move it backwards as well. And now it looks like it's the correct size. And so the next step is we're going to move it downwards such that it's intersecting with the other piece. We'll move it just about to there. Why don't we make it a little bit shorter? Make it a little bit squatter. One thing that's really nice about CAD is a lot of it is kind of just up to your artistic expression. So if I decide I want it to look differently, I could totally do that. And I very much encourage you to do so, because when you have ideas to change little things about CAD, not only are you making maybe an aesthetic edit that you would prefer, you're also helping solidify the concepts within your own mind so that you're not just following along and clicking the buttons that somebody else is clicking. You actually know what each of them are doing and know how you can apply it differently. And that's what's so important in engineering to be able to do. So now we want another one of these, and why don't we just copy, paste, and then mirror it over the vertical plane again. As you can see, I enjoy mirroring as opposed to dragging in new objects. I just think it's cleaner. And now we just want to orient it directly above this other piece. And we're going to move it up one more. There we go. And as you can see, the two pieces are flush. But as you can also see, when I zoom in, I'm now off center. So there are two things I can do to fix this. I can click down with my mouse pad, the little wheel, and I can move it over to the left. Or if I'm off center and I can't figure out how to do that, just like if I were using a trackpad on a laptop, I can hit this button right here, which is fit all in view, or I can click the button F, and then that'll bring this into the center of the screen. So now we can make this all one, or actually, why don't we make this bottom part one object first? So for that, we're going to use the group function. You might remember it from the other tutorial if you've watched that, but I'm going to hit Control G, and now this is all one piece. As you can see, it no longer highlights each of the pieces individually. And then we're also going to turn this into one piece. Perfect. So the next step is to get these rings. So for that, we're going to use the torus shape. So I just dragged it into here, and now we're going to try and align it. So I moved it vertically. We're going to adjust our view. And that looks pretty centered to me. It looks a little bit thick though. If I go to what the chess pieces look like, I want it to be a little bit thinner. So why don't I click this and move this to maybe 3? Looks pretty good. Why don't we go 2.5 though? Perfect. We could also move it a little bit further down, I think. Make it a little bit less obtrusive. Yeah, that looks pretty good to me. Next up, what we're going to do is add another torus. This one's going to be the little ring sitting up here on top of that. Why don't we make sure that's centered? There we go. And this, we also need to change the size actually. As you can see, this inner ring is a little bit smaller than this one. So I'm going to change the sizing by clicking on one of these white corner pieces, which is essentially the bounding box for this piece. And we're going to change the dimensions to, I'll say 16 by 16. As you can see, I need to change both of them. If I just change one, it doesn't automatically render unless I'm holding Shift, I believe. So now why don't I go to top view and reorient really quickly. Again, it's a little bit tall, so I'm going to zoom in and change the vertical distance to 2. And now we're going to move it down just a little bit more so we get some more intersection with our lower one. And that looks pretty good to me. So the next step that we're going to do is use a paraboloid. A little bit more about me. This is actually has been my favorite song for quite a while now, Dancing in the Dark by Bruce Springsteen. Why don't we make sure that it's oriented correctly? I'll move it over just a little bit. That looks pretty centered to me. There we go. You know, now that I think about it, I think this might still be too thick. So why don't we change the vertical thickness of this from 2.5 to 2. Good. And then this, I'm going to make a little bit longer. Not in that direction. There we go. And then I'm going to push it downwards a little further. I might have made it a little bit too long. You know, it looks like this top piece has a smaller bounding box actually. So we're going to turn this into 16 by 16 as well. I'm going to recenter it. There we go. That looks much better. And so on top of that, we're going to put a half sphere. Again, we have to change the bounding box. So I just clicked this here again. And now I'm changing both of these to 16. As you can see, my Z distance is a little bit off. So I'm going to click this, reframe it, and then just bring it down nice and gently so that it connects there. And now we're going to squash it down to 4. And now why don't we make these two a single piece just with group. And as you can see, when you group something, it changes the color just so that you know that it's in a single group. We're going to group these two together as well. And now all we have left to do is add the star on top of the piece. In this case, I think we're going to add a heart instead though. Just a personal preference that in times like these, it's best to show a little love. So here we're going to change it by 90 degrees. So it should be straight up. And now I'm just going to orient it in its correct position. As you can see, it's a little bit big. So why don't we try scaling that down? So as you can see, right now it's shifting down in all directions. And the reason that that's happening like that is that before I clicked on this and changed it, I'm holding shift. And so now as I drag down, it changes all the dimensions equally. So that way you don't end up with a lopsided heart, which nobody wants. Again, why don't I frame this? Perfect. It looks like it's in the middle. Maybe a little bit low. Why don't we move that up a little bit? Also a little bit to the right. So we'll move it left just a skosh. There may be an odd number of pixels. Oh, perfect. Perfect. And now our heart appears to be centered on our chest piece. And now I'm just going to turn the whole thing wood colored just for aesthetics. So I'm going to select each solid body that I've made throughout this CAD session. And we're going to hit group just to turn it into one. And now the color, why don't we choose this? Nice and wooden colored. So as you can see, here's the chest piece we've made today. Of course, there's a lot more that you can do on TinkerCAD. For ideas, you can also just Google cool TinkerCAD projects and then just look around. There are plenty of other tutorials available online for very complicated ones. I recommend starting a little simpler. And to be honest, if you plan on designing anything as complicated as this, or this, or this, I would definitely say that you should consider upgrading to Fusion. They give free educational licenses. or if you have access to one, perhaps learn SolidWorks, as it's definitely the most helpful in industry. Fusion has great integration with 3D printers, as does TinkerCAD, because it's really easy to just export to an OBJ or STL. And then from there, you can upload that to a slicing software called Cura or MakerBot or any other proprietary software that splices it into G-code, which tells the 3D printer what to do. So I hope you enjoyed this video. I'm sure there will be more to come. Thanks for tuning in, and stay safe out there, everyone. Have a good one.